Okay, hey everybody, I'm Simon. I'm going to be teaching you Python over the next few days. The workshop doesn't presume any programming experience. Those of you who've coded before in other languages, or especially in Python, might find the first couple of days a little slow for you, but we need to make sure everyone gets up to speed, and it'll be a good refresher for you all. So the first question everyone wants to know is, why is everyone learning Python right now? You've all come with different experiences and from different disciplines, but Python has become very cool right now within science, especially within computational biology and within bioinformatics. It's a combination of factors. It's partly because it's so widely used and therefore everyone else picks it up. It's become a sort of de facto standard. But it's a very powerful language for processing large amounts of data and automating some more arduous tasks. It's also fairly easy to learn. The way Python is written on the screen looks fairly understandable compared to some other languages. It's somewhat plain English, and if you glance at Python code, you can kind of figure out what's going on, even if you don't understand all the syntax. And there aren't too many weird symbols going on like there are in some other languages, so it's fairly easy to pick up. That doesn't mean it's not powerful. It's a very powerful language. It has a bunch of libraries available to do some of the more advanced things, and it can interface with other languages very well. It really excels when it comes to processing large files. And most of what bioinformatics and other computational biology comes down to is taking some large input file, doing something to it, saving the results of some other large output file. And when it comes to this sort of large data wrangling tasks, Python really excels. So as I say, it's a fantastic first language to learn. It's also a great language to convert to if you're coming from one of the older language. It's sort of people's main scripting language for achieving basic data processing tasks nowadays. For the more statistical side of things, you might want to think about R, and for sort of engineering applications in terms of interfacing with machines or solving equations, there is MATLAB, but Python is a great place to start and can do those things as well. Okay, so the first warning I want to give you is that spacing in Python is important. This is especially significant if you've coded in another language before and are not used to spacing being important. So in another language, in C, for example, you might be used to laying out your code however you want to lay it out, with wherever you want your indentations to be is fine. And there are whole books written on the correct way to lay out code for maximum readability. But when it comes to Python, indentations and the white space at the start of the line is actually significant and is interpreted by Python. So if I typed these two lines, which are the same as these two lines here, except for the white space at the start, one gives you an error and the other will work perfectly fine. So whenever you see on my screen that I've indented some code, I want you to do the same and try and keep the things in line that are in line on my screen. So you can indent with either tab or by pressing space 2 times, 4 times, whatever you think is best, but tab is the normal way of doing it. And make sure that anything that's in line on my screen is in line on your screen, because Python uses that to figure out what's executed when and what code to run when. Okay, so let's get started. The first thing I want everyone to do is launch Python, and to do that you need to launch a terminal, and then what we're going to do is we're going to launch Python and exit out of Python a couple of times just to be familiar with when we are inside Python and when we're not. So when we launch our normal terminal, which in a Mac would be by typing terminal into the launcher, for example, or iterm if you choose a different terminal. And in Windows, you might type CMD to get the command line. You'll see a line that looks a bit like this. It has your username, and it probably ends with a $sign. And after that line, you can type code that talks to your computer. So this is where you would type Linux commands or Mac commands or Windows commands to talk directly to your computer. This isn't Python. To type Python code, we first have to type Python. You'll see some information shown on the screen about what version of Python you're in. And then you should see a line that begins with these 3 arrows, these chevrons. So when you see a line that starts with those arrows, you know that you're within the Python environment and you can start typing Python code. And then I want you to exit out of the Python environment by typing exit with 2 empty brackets, and you should be taken back out of the Python environment and into the basic terminal again, where you can type Python and exit and Python and exit. Just be familiar with going into Python and coming out of Python, and have a look at the start of the line so you know the difference, so that one presumably ends with a $ and the other will end with those three arrows, and that's how you know whether you're typing Python code or whether you're typing commands directly to your operating system. So the first thing we do whenever we learn a new programming language is we figure out how to do hello world. It's some long-running inside programmer joke that I don't really understand the origins of, but we're going to do the same with Python so as not to break with tradition. So in Python, that's very simple. First, we have to type Python to make sure we're in the Python environment, as I say. Look for the line that starts with the 3 arrows at the start. And then from that environment, you can type print, open some brackets, open some quotes, and type hello world, close the quotes, close the brackets, and hit enter. And what you should see is hello world shown on your screen after you press enter. Whenever I talk about printing, I mean printing to the screen, showing text on the screen. We're not talking printers. And so you should, that is how we display the text hello world to the screen. Everyone able to get that working? Awesome, fantastic. Okay, so before we go much further, I'll tell you how to get help if you get stuck. There is an interactive help environment within Python. To get into that, you type help and 2 empty brackets. It'll print a bunch of text to the screen about the help environment. And then you can type the name of a command into this environment that starts with the word help. And it will give you some information about that command. So if you type pprint, it will tell you what the pprint command does. You can then get out of there by typing exit, just by typing quit, and it will take you out of the help environment. Alternatively, if you want help for one single command, you can do this by typing help and then in brackets and in quotes the name of the command you want help for, which is very much like the way we did the print command just now. So if you do help and then in quotes and in brackets the pprint command, it will give you some information about that pprint command. I'm introducing this because this is the sort of standard old-fashioned way of getting help for the Python programming language, but usually what you're going to end up doing is Googling. You're going to type the keyword Python, the name of the command, and you'll get a bunch of results. You'll find a bunch of other people who've Googled the same problem. There's comments, there's useful examples. Google tends to be superior to the inbuilt help for most things because Python has such a large user base that other people will have come across anything you're stuck on before. Okay, so let's get started with programming. And most of what programming comes down to is setting and updating variables. This is pretty universal across any language. If you're used to coding in Java or some of these other languages, you might be used to telling the computer what type of variable you are storing. So you might be used to saying, hey computer, I'm going to be storing a number now, or I'm going to be storing some words now. And there's some stuff that goes on behind the scenes that's different depending on whether you're storing numbers or words. But in Python, it figures that out for you. So to store any type of variable, it's the same syntax. You write the variable name on the left of an equal sign, and then the value you want the variable to have on the right of an equal sign. So I'm defining some variable here called sumText, and I'm setting it equal to these words, which I've put in quotes. We call the string of characters a string in programming in Python. So I'm setting the variable name sumText equal to the value, so this is a string. You can then check the value of any variable by typing the variable name and hitting enter. So if I then type sumText and hit enter, I see the variable value printed to the screen. You can choose any variable name you want. It doesn't have to have the word text in it. You could call it my first variable or a string variable. Whatever you want to name your variable is fine, as long as you're consistent when you're referring to it. So that's how we store some words. Note the quotes here. If you want to store a number, you can do the same thing. You can write on the left-hand side of an equal sign a variable name, and then on the right-hand side of an equal sign some numbers. So I'm storing a value called sumInteger and setting it equal to 42. I can then check the value of that variable by typing some integer and hitting enter, and I see 42 printed back to the screen. You can do the same with decimal place numbers. So if I type some float equals 3.14 whatever, you'll see that it's stored exactly the same. When dealing with true and false values, be aware of the capitalization, that in Python true is capital T lowercase rue or capital F lowercase alse for false. So if you try and store a variable with all caps false, like you may in another language, you'll find you get an error back. Don't worry about getting errors. We're going to be getting a lot of them, and it's fine. So for storing true and false values, which we'll be using quite a lot, capital T and then lowercase. So the capitalized first letter is important. So you've seen we've stored words, we've stored numbers, we've stored true and false values all the same way, with a variable name on the left of an equal sign and then the value for that variable on the right. Everyone follow the way that works? Okay, so when working with numbers, there's lots of basic things you can do. This Python environment that I'm introducing here with the chevrons at the start of the line is sort of like a calculator. You know, it's great for running small little commands, checking the values of basic operations. So think of this as like a very advanced calculator for doing a few lines of code in. When it comes to writing the bigger programs, we're going to be writing things into a text document, doing things a little differently. But for basic checking of tasks and figuring out how various functions work, you can do things within this interactive environment. So when you're working with numbers, everything is kind of as you might expect. If I can define one variable called myNumber equal to 2, another variable called myOther number and set it equal to 3. I can then update the value of myNumber and set it equal to 4 using the same code I did to set it initially. So if you do a variable name equal to some value, if the variable doesn't exist yet, it will create it. If it does exist, it will update the value that that variable has. So after we've run the first 3 lines, myOther number has the value 3 and myNumber has the value 4. So when we do myNumber plus myOther number, we get 7 back. The value that was assigned here, the 2 that was initially assigned, has been overwritten because we've reassigned the value to the variable on the 3rd line. You can do all the normal things you might expect. You can do multiplication and division with an asterisk or a forward slash. To raise a number to the power of another number is 2 stars. And then you can do modular arithmetic, so it tells you the remainder when the number is divided by 2 using this percentage sign. Okay, so as I said, we reassign variables the same way we assigned them initially. So if I have myNumber equal to 4, and then I run this second line, what value is returned when I check the variable of myNumber the next time? Someone shout something out. Lots of people saying 9. Anyone not think it's 9? Great. So yeah, you're right. It's because you'll be 4 multiplied by 2, and then you'll add 1 to it. So the value of myNumber becomes 9 at that point. So you'll notice that it's using the 4 here, multiplying it by 2, adding 1 to it. You can add brackets into your operations as much as you want. They are optional, obviously, when the order of operations is obeyed. But if you want to change the order of operations or just make your code more easy to read, feel free to add these brackets separating bits of your statements. That's fine. Now, some of you might be running Python version 3, and some of you might be running Python version 2 point whatever. So to figure that out, I want everyone to do 5 divided by 2, like this. And if you don't get 2 back, let me know. Anyone getting 2.5? One person getting 2.5. 2 people getting 2.5. Okay, great. So the way division worked in Python up to version 3 was that if you had a whole number on both sides of your division, it would ignore any decimal place information. It would do this sort of integer division where it just forgot about all the decimal place information. So 5 divided by 2 would just get 2. It wouldn't do any clever rounding. It would just show you the 2. So to make sure your code works with any version of Python, the best thing to do is to, whenever you have a division function, is to make sure that one side of your division is a float. So there is some decimal place information on one side of your division. We'll see more about changing the types of variables in a moment, but for now this is the one I want to introduce. If I want to change a whole number into a number with some decimal place information, I cast one side of it to a float. So you type float and then in brackets give it the value. Now when I do my division, you should get 2.5 back. So you can actually cast either side of your division to a float. It doesn't matter. As long as one side of it has some decimal place information, you should be good. So be aware of that. It's very important. Obviously, if you're doing, you write a big script to figure out the gene expression ratios and everything turns out to be less than 1, and then you find out all your answers are 0, it's maybe because you have a division problem like this.